So in order to graph sine, we're going to start the same way we graphed cosine, which is to break out that table of values that you already have. So remember that we filled in that table a couple of weeks ago showing all the sine and cosine and tangent values. Well, today we're focused on the sine values. And basically what we're going to do is we're going to plot each of these points. And remember, as we plot these, the x-coordinate is our angle, and the y-coordinate is our sine value. All right, so we can just start plotting away here. So the first point, notice then, is 0, 0. So let's go ahead and put a point there at 0, 0. The next point is going to go at 30 1/2. Now, just like our cosine one, you might already remember the scale from that. If not, notice that between 0 and 90 here, we have 6 hash marks. 90 divided by 6 is 15, so each of those is going up by 15 degrees. So that means 30 degrees must be 2 hash marks over. So if I'm going to go to 30, 1/2, it means I go over 2 hash marks, and then I go up to 1/2, which is where that little dotted line is, halfway between 0 and 1. Next up, I'm going to go to 45 and root 2 over 2. Now 45 is just one more hash mark over. Root 2 over 2, again, that calculation would give us about 0.71. So I go up to about 0.71, estimate it best you can, at 45 degrees. Then we're going to go 60 degrees, which is root 3 over 2. Remember, the root 3 over 2 is about 0.87. So I'm going to go 60 degrees, which is one more hash mark, because that's 15 degrees past the 45. One more hash mark, and then I estimate going up about the 0.87 there. And again, we can get as close as we can. Doesn't have to be absolutely perfect, because we can only be so accurate and plotting out to like the hundredths place. And then 90 degrees and 1. That one at least should be pretty easy, right? Because we got 90 degrees labeled and we got 1 labeled on there. Having done those, now go ahead and fill in the rest of the points. Okay, and then as you continue plotting points here, the next one in our table is the 120, which brings me to root 3 over 2. So I go over to 120. Notice that's 30 degrees past 90, so that's going to be 2 hash marks. And then that is up at the root 3 over 2, or the 0.87. Next up, I go to 135 degrees. Notice that's 15 degrees further, so that's one more hash mark over. And then that's going to be at 0.71. My next angle is the 150. That's 15 degrees past where the last one is, so we're going to go over 1 hash mark. And that one goes up to 1/2. The next one in my table is the 180 and 0. So I'm now going over to 180 degrees, which notice is 2 hash marks over from my last one, because it's 30 degrees over. Or, of course, I actually have 180 labeled on my graphing grid. So I go to 180 and 0. Make sure you got those correctly plotted, and then keep plotting from there. If all goes well, you should be seeing the rest of them going down in this area. So here are all of the rest of the points that we end up plotting. Then once we apply these points, we can draw the curve that goes through. Now this curve should look a little bit familiar, right? In fact, we're going to be taking a look at all those similarities to cosine here in a moment. But first, we do need to finish out this graph, because notice I've only filled in up to 360 degrees, and we're given all the way out to 720. So just like cosine did, because these are points on a circle and we can just keep looping around the same circle over and over and over again, it's now going to be repeating itself. So we can now just continue taking these points here, just starting from 360 instead. So the pattern is just going to now keep repeating. So go ahead and now fill in the rest of those points to complete your sine graph. All right, this is what you should be looking at now that you've finished putting in all of the rest of the points and the graph that goes through it. Make sure you have this down accurately. All right, so now that we've done that, the big question is, what are the similarities and differences between the graphs of sine and cosine? Okay, so one of them there is they both are the same kind of a wave shape. Okay, that's the same, exactly. What else is the same between the two graphs? Well, what's the midline? Is the midline of the two graphs the same or different?
Same.
It is the same, yeah. The midline for that parent function starts at 0 for both of them, so that didn't change. What about how tall the wave is? Was the wave the same height above and below the midline for both of them, or did that change? That was also the same, yeah. It was going up and down 1. That's actually called amplitude, and we're going to be putting that into our notes here in a little bit. So the amplitude ends up being the same about them. So same shape, same midline, same height. What's different about them? Because it seems like a lot of stuff is the same. So a big difference then is where they start from. Because remember, cosine starts at the top of the wave. Sine starts, as we've just seen, in the middle of the wave going up. So like if we're to take a look at both of those graphs on the same set of axes, here the cosine's in blue and the sine is in red. Notice they have the same height, the same midline, they're the same width. Each of them completes a full cycle in 360 degrees. Everything about them really is the same, except what point in the graph it starts. What point in the wave are we starting from? So for sine, it goes middle, top, middle, bottom, middle. Cosine, it started at the top, and then it went middle, bottom, middle, top. So it's the same pattern, it's the same wave, the same shape, everything's the same about sine and cosine, except for where it starts. All right, so having done that, I'm betting that from here, sine's going to be pretty easy to work with. So I'm going to add in one other little piece here, a little bit of vocabulary. Please add the definition of amplitude into your notes. I referenced it loosely earlier, but now we're going to get the formal definition. All right, and so notice amplitude here is defined as the vertical distance, so it's how far up or down we're going, from the midline to the top or the bottom of a periodic function. Periodic function, you know two examples of periodic functions, sine and cosine now. There's lots of other ones, but these are the only two that you're going to have to be worrying about right now. But this definition does work for any others you might come across. And the other thing to note here is it's the distance from the midline to the top or the bottom. Notice it's an either or, because actually in sine and cosine, the distance from the midline to the top of the graph or to the bottom of the graph is exactly the same. It is always the same. So for instance, if you go up 1 to get to the top, you're going to be going down 1 to get to the bottom. Guaranteed. All right, so we're going to practice doing a couple sine graphs. So above your next graphing grid, go ahead and write this equation. Y equals 2 times sine of theta minus 1. And again, remember that theta, it looks like a 0 with a line through it. It's just a Greek letter. It works just like x would. It's just a variable. It just is that when we start dealing with all these angles, Greek letters are often used as variables, so we kind of got to start getting used to it. All right, so we're going to be making this graph. Now, first of all, I want to get through a little vocabulary here. What's the midline of this graph going to be? -1, absolutely. Because the midline is determined by however far it's been moved up or down. Now, what is the amplitude of this graph going to be? 2, absolutely. The amplitude is always determined by the vertical stretch. They're really the same idea when it comes to sine and cosine. And so the amplitude here is going to be 2. Now, a great way to start this graph is to actually draw in the midline and lines for the top and the bottom as well. Make sure they're dotted. So I'm going to start by drawing in a dotted line down at 1, down at -1. So there's my midline. And then my amplitude is 2. The amplitude being 2 means that I'm going to go up 2 from there. And I'm going to go down 2 from there. Notice that distance between the midline and the top and the bottom is both 2. That is what amplitude really means. Alright, so now that I've drawn those in, I can go ahead and start making my graph for sine. The big thing I need to remember, for sine, where does it start? The top, the middle, or the bottom? Middle, absolutely. So my first point, it goes on the midline. And then, starting at the middle, it could actually go either way. It could go up or down. So for sine, which one should it be? Should it start by going up to the top or down to the bottom? Top, yeah. It next goes up to the top. That's just like our parent function that we graphed earlier. And then from there, of course, it follows the same pattern as what cosine did, so you already know this pattern. If I went middle, then top, it's got to go middle, bottom, middle after that. So we can go ahead and plot those points. Each of those points goes at 90-degree increments and is plotted on either the top, the middle, or the bottom line. Once you plotted those points, go ahead and draw the curve that goes through. Now, if you, again, are having any trouble making the curves come out looking good, remember that you can also plot a few more points in there. For instance, like 30 degrees and 1/2, you could plot that point. But you only have to do that if you're having trouble getting the curves looking good. If you're able to get the curves looking good without it, feel free. Then lastly, today we're going to be graphing this one together. So please write down this equation. And then you're pretty well versed with these. See how far you can get on making the graph. Because it is so similar to cosine, you can use the same techniques. See if you can make the graph from there. All right, so first thing I'm going to do is I'm actually going to go back to that vocabulary. First up, the midline. The midline here is going to be up 2. So that's actually the first thing I'm going to draw on my graph is the midline up at 2. From there, also the amplitude. Well, there's no number written in front of sine, which is where we normally get our amplitude from. So what is the amplitude? The amplitude here is just going to be 1. Now, if you're thinking, wait, couldn't it be -1 because of the negative? No, amplitude is actually always positive because it's a distance from the middle to the top or the bottom. The negative will reflect it, but in terms of amplitude, it's just a straight 1. That tells me I'm going up 1 and down 1 from my midline. And then I can start looking at plotting some points. So notice we got theta minus 90 here. The minus 90 tells me to start right 90. So instead of putting my first point here at 0 on the midline, my first point's going to go here at 90 on the midline. So far I have used the 90 and I've used the 2, but the negative hasn't actually entered into it yet. And this is the point at which it's going to. Because normally I would start in the middle for sine, and then I'd go to the top. But the negative changes that. The negative tells me that instead of going middle top, I'm going to flip that upside down, and I'm actually going to go middle bottom. So notice what the negative does. It flips it upside down. So you still start in the middle, because 0, if you flip it, is still at 0. But top becomes bottom. And then bottom will become top. So we can go ahead and plot those next points. Now, so far, that gives me part of my graph over here. Tells me this much. But I still need to fill it in. You always have to fill in the entire grid going left and right. So it's not like this is the finished product here, because this graph goes on forever. So notice where it's at right now. If I were reading this right to left, I'd be seeing myself as going up at that point. So that tells me that I have to be going up to here. So the next point over here on the left is going to be top. And so I can go ahead and finish making my graph that way. One little note on that. Another way to know that is because I was graphing 0 to 360, 0 and 360 should always be the same. Because remember, 0 and 360 are coterminal angles. That is, they're the same point on the circle. So that's another thing you can look for as you make these graphs. 0 and 360, you should be at the same place.